I was recently watching this interview where Joe Rogan was asking Neil deGrasse Tyson some questions about the universe. And one of the things that he brought up was that the James Webb telescope was pointing out that the Big Bang probably didn't happen. If you haven't kept up with this, the deeper we look into space, scientists and astronomers who are evolutionists have predicted that things would be more and more scattered, but that's absolutely not what we're finding. Well, as atheists and agnostics always do or often do, they usually scoff anybody who believes differently than them. And so Neil deGrasse Tyson was made like, I don't know what scientific pages you're looking at. And there's this scoffing towards Joe Rogan, who was or actually engaged and wanted this man's knowledge and opinion. Now, what I find fascinating is intellectuals who, they know they're smart, but they have to scoff and ridicule people. And then how the people that are ridiculed will actually lift them up further. Like, there's some kind of sick interaction there that I just don't understand. But anyhow, so as Neil deGrasse Tyson was answering this question, what he was trying to say is that science, refines itself. It is never overturned, but it's just refined or modified. And so, don't worry about all that. But I have found that pretty much any time that Neil deGrasse Tyson's mouth is moving, that I can look for misinformation or maybe even flat out lies. And so as he was explaining this, he was talking about the problem with the orbit of Mercury. And so for those that are not aware of this, Mercury has like an egg-shaped orbit of sorts. It is the only planet that doesn't have this circular shape. It actually has an egg shape to it. And Neil deGrasse Tyson went on record as saying, there's only one explanation. And so basically we had to leave Newtonian mathematics behind and jump into Einstein's theory of relativity, and that's the way to explain it. The problem is, as soon as I heard that he said there's only one way to explain this, I was like, all I have to do now is research this. And I have run across 3 other methods that can explain the egg-shaped orbit of Mercury. And I'm not saying these are valid or whatnot. What I'm saying is there's alternatives, and that he wasn't even willing to consider these. And I will say some of them are actually pretty good alternatives. Starting with the least favorite one, there's this Indian scientist that is claiming that because Mercury is the closest to the sun on the inside of its orbit, as it's getting closer to the sun, it is pulled faster momentarily, and so it skips ahead, and that is what pulls it into an egg shape rather than the long circular model, etc. And then some others have speculated, well, if the sun is oblated, meaning it's fatter in the middle, it's not just a circle, then that would pull on the orbit of Mercury and make it, different. And then others have said there is actually evidence within the sun that the core of the sun is turning at a different speed or at different times on the outside, and that could affect the gravity and the pull upon Mercury. So my point being, there is not just one explanation for Mercury's travel path being different than the rest of the planets. But Neil deGrasse Tyson is committed and says, there's only one explanation. Maybe he means there's only one real explanation, but the way he touted it was with authoritarianism and professionalism, and you just trust us, we're the experts, we know what we're talking about. And so you find then that he's like, well, Einstein's theory of relativity explains the path of Mercury, whereas, Newton does not. Now, it has just recently come to my attention that there are about 3,000 papers and or books that are all written that are concerned and address the problems with Einstein's theory of relativity. But why isn't that getting pushed? And so I was like, what is this connection here? Why is this attachment to Einstein's mathematics or his theory of relativity. And you come to find out that there is a difference between the Ptolemaic and the Copernican models of the universe. Now, even though they both have the same mathematical distance between the Earth and the Sun, even though there's this rotation of one object around the other or vice versa, there's got to be some dynamic there of why we would accept one model over the other. Now, it is very interesting at this point to note that Einstein himself and Stephen Hawking, I think both of these guys have a lot of credit, whether they're wrong about things or not. They have a lot of credit when it comes to science, but they both said that the mathematical differences between the Ptolemaic version of the universe or the Copernican model, one is not better than the other. One does not mathematically outperform the other. They are both equivalent. Now, if you start analyzing this, like, why would Neil deGrasse Tyson then and pretty much every other scientist out there, why would they cling so heavily to the Einsteinian theory of relativity and his way of explaining the motions of the universe? And it's because he leans towards a sun-centered universe. And this is my opinion going forward from this point, but others are highlighting this. And I think this is absolutely worth noting. But if you've got two models that are identical in their mathematical formula, except that the application of where the sun is the center or the earth is the center, the outcomes, though, are drastically different, and I will try to explain what that is. So number one, if you are in a void, how do you measure anything? You have to have some kind of way of measuring it. You've got to, what are you going to get a string and measure across the void? You've got to understand that when you're in a void, which is what space is, measuring things becomes a bit ambiguous, and it becomes very, very hard to be authoritative on what is moving and what is not moving. And so you need to understand that there is a choice here between having a sun-centered universe or an earth-centered universe mathematically. Now, the reason that I believe that Neil deGrasse Tyson would hang on so heavily to the sun-centered universe is because of a thing in the stars called parallax. Now, the way we calculate how far away the stars are is we basically log the position of where certain stars are in the sky, and let's say we do it in the spring of the year, and then we come back later in the fall of the year, or, a 6-month time period, and basically then the Earth has orbited around the sun all the way to the other side of this massive orbit around the sun. And because of that massive mileage difference and the little tiny movement of the star above, we can calculate how far away the stars are. Oh, it's a beautiful formula. I mean, it's trigonometry, and trigonometry is real math. But again, the problem is, in a void, how do you define where something is or where something is not? And so basically here, you've got the Earth being this far away from the sun, but that distance is doubled, and then you add that into the formula of your parallax, and you get some distances for how far away these stars are. But what if you reverted to Newtonian math? And Stephen Hawking and Einstein both said Newtonian math. Oh, they didn't say. They said that the Ptolemaic and the Copernican systems, the Earth-centered or the Sun-centered systems, are mathematically equivalent. What if we tried to measure how far away the stars were by that method? All of a sudden, you understand why an astronomer would say, there's only one way to truly measure Mercury. Like, there's only one true method for measuring Mercury. Because if you begin to look at other measurements, you'll find out that the stars might be a whole lot closer than science would like you to believe they are. Now, if the stars are a lot closer, what does that mean? Well, all of a sudden it begins to cut down upon the age of the universe. And anybody familiar with evolution knows you need some incredible expanses of time as the magic wand to erase all the it's not possible transitions. And so, you got to keep these mathematical secrets, and you can't let anybody, in on those things. Like we had to leave Newton behind and go to Einstein. Well, I want you to know that as a human being, I like Einstein. I liked reading Einstein. I mean, how amazing it was when I first started reading about that. At the speed of light, time slows down. I'm like, wow, that's so cool. And then at the speed of light, things get infinitely heavier. I don't know if it's infinitely, but, vastly heavier. I'm like, that's so wild. I mean, what is going on? And then things shorten. And then I started reading about these experiments that proved these things. And it is so fascinating. And here's how fascinating it is. It doesn't just fascinate intellectuals. It actually fascinates all of humanity, or a lot of humanity, because, like, you ever heard of Star Trek? You ever heard of this whole Star Trek series? The concepts about traveling through time or through wormholes or going at warp speed or going, here and there throughout the universe, all of those concepts are offshoots and outsprings of Einstein's theory of relativity. Now, his theory of relativity said some wild stuff, like that things slow down, or time slows down at the speed of light. And wow, that is fascinating. But how do scientists get to start peddling fascination? Well, that's an interesting story. And it slightly dives back in to roughly the mid to late 1800s, where David Hilbert wanted to free us from the constraints of the constructs of mathematics. Basically, maybe math to him was too limited. And so the way you most likely view science, and the way science should be viewed, is that it is objective. We are measuring real things. We are quantifying real things. We are testing real things. And actually, that is real science, if that's what we are doing. But when all the mathematics previous to David Hilbert actually dealt with math that was grounded in reality, let's say lengths or weights or actual distances or time periods, things very measurable. But David Hilbert wanted to expand off of that, and so he began to root mathematics in ideology. And actually, once he had wrote his grand mathematical thesis, he actually presented it to be presented to others, and one critic of it said, hey, this isn't mathematics, this is theology. What kind of mathematics would so deviate from reality that it would be called theology? And when you begin to see that David Hilbert opened up the door for mankind to have what I would call non-objective mathematics, mathematics that don't have to be grounded or rooted in reality, then you begin to be able to put mathematical constructs upon anything. Just like I am free to lie with my lips or create things in my mind that may or may not be true, then I could create some kind of idea, slap a mathematical formula upon it, and even though we can extrapolate a real process from it, if you start with something imaginary and you have a process and it ends, you have no way of testing it to see if it is now imaginary or real. Since it was grounded in imagination from the beginning, it ends in the imagination. There is no way to firmly, concretely ground it. And I believe it was Gödel that came up with the incompleteness theorem to prove this. He's like, listen, with this kind of mathematics, you're never going to be able to actually prove anything. So you see, math before that was, once it was started in objective reality, it would finish in objective reality, and thus it was very good math. But after David Hilbert came along, all the secularists became free. They were like, we get to create mathematics. And thus, when you're free from mathematics, you can create mathematics. And this is one of the reasons that Einstein had the freedom, Because general relativity, if I'm saying this correctly, general relativity never actually quite works without special relativity being thrown in. And from what I've heard some scientists call this, the special relativity is the fudge factor. So basically, if the math doesn't work, you need a range to be able to make it work in. You need the freedom to be able to create new and stellar and fanciful ideas. Now, this basically opens then science for a free-for-all. As long as you can contribute to the fanciful stories that were before or elaborate upon them, then you would be free to be a part of the club. But if you tried to ground such things in concreteness or go against the norm, then you'd be excluded. And this is absolutely the case. I don't know about you, but it's becoming very clear to me that one of the things that makes Christianity so special is that we have a creator God who spoke things into existence, and that's amazing. We have a sustainer who holds all things together by his might and power. We have a mysterious God who can do miracles. We have a mysterious God that plants the Holy Spirit within us. And those are great mysteries to worship. But it now becomes very clear to me that science has to offer these grand mysteries as well to get people to worship it. I don't know about you, but what I'm going to do is I'm going to stick with things like archaeology and written history and the parchments and logical deductions, things that actually confirm and validate the historicity and the actuality of Jesus Christ as being the creator of the universe. See, I can objectively look at and test Christianity and the Bible and the things of the Bible, and it comes out that it is reality, whereas these other things tend to evaporate into thin air when they are checked against the truth.